Hi everyone, welcome to this lesson. In this lesson, we're just going to expand on a statement I made earlier in previous lessons about why we should pass as InOut or by reference. Why should we move information around our project via the InOut interface where we can. So to expand on that, what I've got here is a program and a function block, and in my program I'm just calling the check data function block. In my GVL here, my global variable list, I have quite a large amount of information. So I've got a two-dimensional array, which is an array of noughts to 2047. So there's 2048 elements in this array, and that type is another array of 0 to 2047 LREALs, which is the biggest data set that I can make with standard variables. So the length of this is very, very large to be moving around my project. What I have here is a in-out, so I'm passing by reference. And just to show, sorry, I'm in simulation at the moment, so that's why things are sort of on, and I can see this information in the interface, such as reference to array, etc. So I've still got access to all of this information in here, but I'm passing by reference. Now I can visualize this and the difference this makes by going to my task configuration. If I go to my task, well, first off, we'll just have a look at main task and show that we are currently freewheeling. So this PLC is trying to run this task, which is the PLC program here. See, I'm calling it here. It's trying to run it as fast as it can. And if I come and have a look at the task configuration on the monitor tab, you can see my main task here, and the last cycle time is what we're interested in. So this is nanoseconds. So it's taking, on average, which we can see here, 9 nanoseconds to move all of that information around and perform what I'm asking check data to perform, which is simply adding two of these values together and placing them in another value. If I were to change that interface, so if I come offline and I change that to input, and I need to create another output because we're actually adding information. So this now becomes data in, and this becomes data out. Copy that there. So this is, you can do this for structures as well. These could be the same data type on structures. What I have now is essentially the same thing because it wasn't in-out. What people tend to think is that you're moving all the information in, doing what you need to do, and passing all the information out, which isn't the case. You're by reference. Or in Siemens, you'll see that it's a pointer to. You'll actually see that in Siemens, the pointer from the outside of the block, the symbolic information clearly shows that it's a pointer. So let's just change these to data in and data out. And then what I'll do is I'll download this again, and we'll see what the difference is in this average runtime. So bearing in mind, before we were about 9 nanoseconds, what we should see now is a substantial increase because we're no longer passing by reference. We're no longer passing by reference. We're now actually copying that information, and this is a big data set to be copying. So let me download. I'll do a proper download. And run. So everything runs fine, and there's no real difference in what we're doing. The logic is exactly the same. I'm still using the same data set, so we're copying all the information in. I'm doing the addition that the check data is doing, and then I'm passing all the information out, which is no different to what we were doing before. However, looking at the task configuration, our average cycle time is massively bigger than it was before. And this is down to the copy function that needs to be done on moving stuff through that interface. So if you've ever come up against this before, where you're trying to move large pieces of information around, or you're doing many moves on an interface, some people might have function blocks that have in excess of 100 inputs, for example, because everything's broken down into small elemental interface properties. You're doing yourself a disservice there in terms of the amount of time your PLC is taking to copy that information across. And this becomes a real problem when people start making big function blocks that have lots of other function blocks inside that is sharing the same information, but they're using inputs and outputs as interfaces, because it's copied every single time. Every single time you pass through an interface that uses inputs or outputs, you're copying that information. And it's not a very obvious thing. And for the most part, it's not really a problem. It only becomes a problem when you're using a smaller PLC, but quite a lot of information, or over time when you start sort of making modifications to projects and they get bigger and bigger, it can become a problem then. But if you use InOut and structures, it's never a problem in the beginning, and you can have much faster performing programs with really no downside. So it's definitely worth getting into that habit, and I hope this demonstrates why using InOuts, especially with structures or large data sets like this array, really has why it has such a good benefit in doing so.